Good morning. My name is Ken Powaga, and I'm from GFK Loyalty. And with me today is Sean Magnum, who's from our Marketing Science Department. And in case any of you didn't miss it, we're talking about Shapley Value today. And yesterday, after 60 years from developing the Shapley Value, Lloyd Shapley was awarded the Nobel Prize. So this is kind of good timing for us. First, let me just spend a little bit of time introducing you to those who don't know who GFK is. We're a global marketing research firm headquartered in Nuremberg, Germany, and operating in over 100 countries. In the U.S. alone, we have 900 full-time staff and 27 offices. The ownership is with the GFK Association, which is dedicated to improving marketing research in industry. Our organization is a matrix organization. We have a number of units that specialize in specific industries, all the way from automotive to government, education, and then we also have some subject matter experts or product areas. My product area is in customer loyalty and customer satisfaction. And as far as customer loyalty and satisfaction goes, what we really need to do is not only measure what customer satisfaction is, but provide prescriptions on what's the best way to improve it, improve loyalty, and all the good things that go along with loyalty, retention, buying more, word of mouth. And in order to do that, we wanted to start with basically two things. First, we have to understand how customer satisfaction and loyalty work, and we need a model of customer satisfaction and loyalty. And then, instead of just taking things off the shelf, common analytical tools to define that, we needed to find the right models to fit. And the models to fit are those that do the best job of explaining the outcome variables that we're looking for. And in customer satisfaction, there's a couple. One is satisfaction, and the other is loyalty. And the outcome and the explanatory variables are performance on various needs and expectations of the customer. So, in order to get to strong customer relations, it's very simple. You need two things. First, deliver what you say you're going to deliver and avoid disappointment. But in today's industry, with tremendous competition and many choices available, that's not enough. The second thing you need to do is to delight the customers so that they build a bond with you and are not lured away by the competition. And this is really, when we looked into what this is actually the Kano model of customer satisfaction. Noriyako Kano was a leader in the total quality movement in the 80s in Japan, a disciple of Deming and Duran, and he applied from Herzberg in the employee satisfaction, employee engagement area, his model to customers' engagement and customer satisfaction. And that's the hygiene, motivator hygiene theory. And basically what he says is that satisfaction is a nonlinear function of need fulfillment. And I'll get into that a little bit more. And he defined three different types of needs that each have a different function on how they work with bringing customers to true loyalty. The first are basic needs, and these are the must-haves. These cause satisfaction, and what we're plotting here is the performance on the specific need and the impact it has on overall satisfaction. So in this case, the basic needs will cause dissatisfaction if they're delivered poorly, but delivering them well is not necessarily going to give you high degrees of satisfaction. Example, maybe if you go to your hotel room and it's not clean. You expect it to be clean, that's not going to bring you to high loyalty, but satisfier. But having 6 rolls of toilet paper is not necessarily going to be a high degree of loyalty.
Unless you really, really need it.
If you've been to some of the Mexican... The second area are the more traditional performance needs. More is better. If you're checking in, if you check in immediately, that's great. If it takes you an hour, that's not so good. So it has a dual effect on satisfaction. And the third area are the excitement needs. And these are the things you don't miss if you don't get them. But once you get them, they lead to high levels of satisfaction and loyalty. And if they put a little cookie on your pillow or mints on the pillow, that might be a good idea of an excitement need. The other thing about the Kano model is that there's migration in this. That what was once excitement and performance needs migrate to become basic needs over time. So what we do, we want to understand what are the explanatory variables for satisfaction. So we need to break the model into two parts. The first part we call key dissatisfiers. And these are the areas that are operating in this function. When there's poor performance on a specific attribute, it leads to poor overall performance. And we call this the key dissatisfiers. And they drive dissatisfaction. The second area is what we call key enhancers. And these are excitement and performance attributes that drive overall delight and high degrees of satisfaction, or even beyond satisfaction to high degrees of loyalty. So we have a two-part model. And so what we say, well, how does this help our clients decide what to work on? And we use the analogy of if you have a boat to sell, and this is a pretty crappy boat, so you have that to sell. The first thing you need to do is to fix the holes in the boat so that it floats. These are the key dissatisfiers. If there's holes in the boat, it's going to sink. And the second thing you need to do is to put a new coat of paint on it to make it saleable, to cause enhancers. The other part of the Kano model that's really interesting is that it's not an additive model. That disappointment on even one key dissatisfier can lead to overall disappointment. And the same with some enhancers. If they're happy with one, it's not a little bit of this, a little bit of that. And especially on dissatisfiers, because the other part is that enhancers on a true key dissatisfiers cannot compensate for poor performance on key dissatisfiers. So the next thing we had to do is define the particular model to say, how do we set priorities, how do we set the impact of various attributes, both on dissatisfaction and on customer delight. And some of the properties that we had to look at when we were looking for an analytical tool are, number one, it's a nonlinear. Poor performance on some attributes lead to dissatisfaction, but outstanding performance on others on those same attributes do not necessarily lead to high performance. And for some other attributes, outstanding performance may lead to delight, but if they're missing, they have no effect. So the implications are that we need different importance measurements for each of the measured attributes for dissatisfaction and for delight. The second part of this, and very important, is that it's a non-additive model. That poor performance on even a single basic or performance need can lead to overall dissatisfaction. And likewise, excellent performance on even a single excitement or performance need could lead to customer delight. So in marketing research, regression has been around forever. And linear regression or even nonlinear regression. The problem with regression is that it is an additive model. We have a dependent variable that's predicted by a little bit of this, a little bit of that, a little bit of that. So we had to look beyond the typical regression, Liz-Roll, all those types of models to define what is really driving dissatisfaction and what is really driving delight. So luckily, we found in our Nobel Prize winner in economics yesterday from Lloyd Shapley. The answer appears in cooperative game theory. The basic parts of cooperative game theory is that you have a set of players with a common goal. Our players in our case are the attributes that we're measuring. The common goal is their relationship with either dissatisfaction or delight. and outcome variable by different subsets or combinations of variables. So it's not only looking at each variable as independent of each other, we want to look at variables in groups or sets. And we want to allocate a value to each attribute or player. And this is what Lloyd Shapley did almost 30 years ago at Princeton in coming up with the Shapley value. And the value that, in just shortly what the Shapley value is the average value of the combinations that include a player less the average value of all those combinations that don't include the variable. And hockey is kind of an example. When we used to play hockey in the US, now that they're on strike, it's not there. But you think about it, hockey, there's a lot of substitutions. And there's 5 skaters and a goalie on the ice, and the 5 skaters just keep changing every 2 minutes, every minute or so. So how do we understand what is the value of any player? We need to look at how well the team did when that player was on the ice versus how well the team did when the player was not on the ice. And Shapley value would be very important for that. So where in hockey, the value that we're trying to maximize may be what's called in hockey a plus minus. Scores, if they score, it's plus. If the opponent team scores, it's a minus. In our case, what we really want to look at in the value of the function that we're trying to maximize with the Shapley value is what we call reach minus noise. And reach is the percentage of customers who are dissatisfied overall and who are dissatisfied with the attribute in the set. And the noise are the opposite of those who are happy overall, but they have dissatisfaction with one of the attributes in the set. These you might call a false positive. So we want to maximize and find the group of attributes, and more importantly, we want to find out how much each attribute adds to that group with the Shapley value. Now this is the formula for the Shapley value. I'm a marketing person. Sean is the statistical person, and this has a lot of Greek letters in it. But basically, let me explain what this is. This is the Shapley value for if we have n attributes in the set, and this is for attribute j. What we need to do is to look at the sum across all the different combinations of attributes. And we need to calculate for each of those combinations the reach and noise of those that include attribute j and subtract it from the reach and noise from those who do not include attribute j. And because there's different number of attributes in the set, we need to adjust with a weighting. And this is a result from some studies that we've done in the financial and branch banking area, which shows how the Shapley value ranks from a customer satisfaction survey in banking. And in this case, branch wait time had 3 times as much as the averaged impact on dissatisfaction in any other attribute. And some others had no impact, meaning if there was dissatisfaction with them, there was probably just as much likelihood that the person was satisfied as not satisfied. The second part of it, then we look at the top end of the scale. We look at delight on each of these attributes and how well it is impacting on overall high levels of satisfaction, overall high levels of loyalty. And we come up with a different set of Shapley values, and this becomes the key enhancer part of our model. So in a sense, what we've done with the Shapley value is we define attributes that can fall into 3 categories. One category is a dissatisfier, where they do not affect overall loyalty, but they have a tremendous effect on dissatisfaction. On the other side are the enhancers, which have the opposite effect. They create delight, but they don't necessarily cause dissatisfaction. And in the middle, we have things that that operate in both areas. In the past, this was the only thing that we identified from regression analysis. Now we've given our clients the opportunity to set priorities. And the priorities that we set, we look at performance first in a negative way, percent dissatisfied versus key dissatisfies, and the top performance is to fix the hole in the boat. The fix key dissatisfiers where there's a high level of dissatisfaction. The second priority is look at the enhancers, and where you're doing poorly on an enhancer, this is something you want to create more delight. And so that becomes the second priority. If you have an enhancer where you're really doing well, that's something you can promote. It could be a competitive advantage, and our clients use it for that. And finally, the fourth area, there's nothing on this chart in there, but many times there's a little bit of dissatisfaction with an attribute, but it has a high impact. These are things you want to just monitor and make sure you don't make any changes to. So, that being said, with over 100 offices all across the world, we wanted to make sure that our analysis is done for all our clients, whether it's in Belarus, Peru, Philippines, or in New York or London. It didn't matter, and each of those areas had different levels of statistical skills. So we wanted to take the statistical background of our model and put it online. So we created an online tool that GFK employees can have access to. It's a secure tool. And what this does is it enables them to download their data, and the first line of the first row of the data are the labels of all the dependent and independent variables, as well as any other type of filter variables or weights that they may want to have. And down through the rest of it are the scores from each respondent in our customer satisfaction survey. And so they first do that, and then the next step that comes up, it enables the user to identify what they want to use for a dependent variable for the dissatisfier side of it, and what they want to use for a dependent variable on the enhancer side. And in this case, we use different ones, but in some cases you can just do it on the basis of satisfaction. High satisfaction for enhancers, low satisfaction for dissatisfiers. But in this case, we use satisfaction as a dependent variable for key dissatisfiers, and a loyalty score that's a composite of some various outcome variables. You may have heard of NPS, but there's other types of variables that could go into a really robust loyalty score. And that's what we'll present next year and why our loyalty score is better. And then you have a list of explanatory variables, and these are things like branch wait time, et cetera, et cetera. And so the user can select which ones they want to include. They also have the option to weight the data, if there's a weight variable in there, and they have the option to filter on various demographic information that may be there. The next step is to set the parameters to tell the computer, number one, what scale are you using? What's the minimum scale and the maximum scale? And this, saying for satisfaction, we have a 5-point scale, 1 through 5. 1 and 2 are kind of dissatisfied, 3 and 4 are just satisfied, and 5 is completely delighted. So then we have to identify what do we want to declare as dissatisfaction. So the minimum dissatisfaction is 2, 1 and 2 are dissatisfied. The minimum delight is 5. Then we need to identify the key enhancer variable. In this case, we have a 100-point scale that we use as a combination. And here it goes from 0 to 100, and anything below 60, 59 or below is considered poor, and anything above 90 is considered excellent. Then we want to define what scales we're using for the dependent variables or the explanatory variables. And again, this is a 5-point scale. On each of the attributes, we ask a 5-point scale. The bottom two are dissatisfied. The top is delighted. So we pull this in there, give some information about how many explanatory variables you have. So in case you're missing something, you say, oh, I should have had 25, and you go back and make sure you had the 25. So then the next step, we get into calculating the Shapley value. And we order the attributes in order of their Shapley value. We show what the actual Shapley value is, and we show the impact of indexing that to the average. The average is 100, so in this case, attribute M has 4 times the impact. And then we allow the user to select the best combination, keeping in order of Shapley value, to maximize the reach minus the noise, or our objective function. And that's the function that we're trying to maximize with the Shapley value. And in this case, first, second, third, fourth one, and then it starts falling off. And what this shows is the reach of those 4 attributes. Anybody who's dissatisfied with any one or more of them is about 90%. And the noise is about 30%, 37%. So then the second part of this is we run the key enhancers. Now the point in our key enhancers is because we believe that satisfaction is a necessary but not sufficient for true loyalty. So we take out of this analysis anybody who is dissatisfied with any of the key dissatisfiers in the first part. And we just work with those who are satisfied. And we break the sample into 2 parts, not delighted with any in the set versus delighted with any attribute. And we do the same type of things with Shapley value, order it by Shapley value. And here, a few more attributes came in before we were able to maximize the objective function. Then we're done. But we wanted to download this in a standard format. We downloaded an Excel file, which is exactly the same file that people threw in, plus a couple of segmentation based on our analysis. And then we also download a PowerPoint to have more of a standard way of presenting the data. And the first PowerPoint that's from the download tells us what the key dissatisfier dependent variable is and what the scores were on those. And it shows the attribute importance, how much of overall dissatisfaction was explained, and it categorizes these into fix and monitor based on what an average fix and average score would be. So this provides clear direction to say attribute K, fix, attribute V, fix. And then the second slide is the key enhancers. Again, we had a different dependent variable, and we played this off the strong side, and this breaks it down into those that we want to promote and those that we want to improve. Another thing that we do add to this is that because each respondent can be then classified into one of 4 categories. And what's really important is that the hostage category are those who have dissatisfaction with the key dissatisfier, but have relatively good loyalty scores. And these can be tracked over time. We can then look at the people who are loyal advocates and see, well, did they stay? Did they leave? Versus the people who are exit bound with a low loyalty score. And when we've done this time and time again, the loyal advocates have 3 or 4 times the lifetime value of exit bound. And also, this gives some indication of what we need to work on. If you have a lot of hostage that you want to move over to here, you want to fix the key dissatisfiers. If you have ambivalent, and that means that they have almost a moderate loyalty, but they're really not dissatisfied with any of the key dissatisfiers, you work on the key enhancers. And we can graph it and show the various categories. And these all come out automatically for the analyst in the local countries to use. And over the past 3 years, this has been used in over 30 different GFK companies across the globe, 150 users, and over 4,000 runs. Okay, thank you. That's.
That was good timing.
I